Okay, for those of you at home, I just want to go through the basics of what you're going to cover for your lab this week. Since you're at home and not able to do everything in class, I want to just give you a couple of pointers for how to do a couple of these activities. You should be able to do everything at home except for the actual blood pressure measurements, since I assume most of you don't have your own blood pressure cuff at home with a stethoscope and everything. But everything else you should be able to do. We did use BioPack in lab this week, but you can do it without. You just might need a little bit of help from a friend or a family member if you can get somebody to help you. You can just measure your own pulse in your wrist. Just be aware that you mentally thinking about your pulse or heart rate can kind of influence what your heart rate is, because it kind of affects your breathing and whatnot. So I suggest having somebody help you with that if you are able. So I'm just going to share my screen and show you a couple things on the Word document. Then I'll go through kind of where I have things on Canvas and the most helpful tools that I can give you to complete this lab. So the first thing is just going to be this Khan Academy video. It is like just a 5-minute video, so it should be pretty quick. It goes through what blood pressure is and how it's measured. So it'll just cover a few of these first questions. The dichrotic notch is not on your video. You should be able to find that in your textbook. I like to draw an actual visual for what the dichrotic notch is. Just that way, when you go back to study for the practical, you can just get a really quick visual reference of what it is. And then you should be able to find in your textbook what's happening during that. So a sphygmomanometer is what you would use to measure blood pressure. This is something that you can't do at home, but on the Canvas page that I made for this assignment, I posted a video by Osmosis, which is a pretty common online platform, and that they have a lot of videos for like nursing and med school students. So it goes into a lot more detail than you need. So I think it's just about 30 seconds to about 3 minutes, 2.5 or 3 minutes of that YouTube video. So definitely not the whole thing. But if you've never measured blood pressure before, or if you just kind of want a little bit of a refresher, maybe you learned it for CNA, but you didn't really understand what you were doing at the time, watch that video. It should be a really clear outline of how it works. And then next week, if you are back in class, we can pull out the blood pressure cuffs, and you are welcome to give it a shot measuring that actually in person. So the key things that you'll need to do here are just the actual calculations for pulse pressure and mean arterial pressure, which are both equations that you get from the two values that you would get from measuring blood pressure. So you get your 120/80, or whatever your blood pressure two values are for systolic and diastolic pressure. Remember that systolic pressure is when the ventricles are contracting. So that's when the highest amount of pressure is going to be on your aorta and all of your other arteries coming off of the heart there. So those major arteries. So systolic pressure is going to be the higher number. So that 120 number would be systolic. And then diastolic pressure is when the ventricles are relaxing. So that kind of at rest position of the aorta and the other arteries. That diastolic pressure is the amount of pressure on those vessels at that time coming out of the heart. So you can calculate pulse pressure just by finding the difference between the two. That's a very, very common number used in just kind of saying, do you have good cardiovascular health? And if that number is high, it means that you have too much pressure on the aorta, or just coming out of the heart in general on your major arteries. Usually that's because you have some stiffening going on in the arteries. So if you have like plaque buildup, or you've lost some elasticity, or if your heart is larger than normal, which can be caused by a variety of factors, that is all going to increase the pulse pressure. Everyone our age, for the most part, your age, up through 30s and 40s, it's typically not a huge issue, but can become an issue because of health, diet choices, but genetics has a huge impact on that as well. So these are really, really common tools used to just get some base measurements to keep track of your cardiovascular health. So even if this isn't something that you'll ever do, if you're not a nursing student, if you're just exercise science or athletic training, it's still something that you'll probably get measured several times throughout your life at the doctor. And, hopefully you're always healthy. So you won't be able to do 4 students here, obviously, for these. I can give you some values for that if you want to. Otherwise, you can leave this blank and just let me know that you were absent in class. And then just do the calculations down here using these 120/80, which is, a pretty normal value for blood pressure. So you can calculate mean arterial pressure. Number 4 on this is asking you what is going to cause an increase in pulse pressure. So I just talked about that a bit, but I also posted a video on the Canvas page and a link to the Mayo Clinic, which has just a really, really short article about what can increase pulse pressure. So go ahead and read that and you should be able to figure out what would cause that. For these major arteries palpated, your textbook, and let me actually just pull up the book really quick and I'll show you kind of what these look like. Okay, so in your book on page 717, they have this image here. So you use this when you're trying to figure out what the different places that you would palpate to feel pulse in your body. We're only asking you for 3 of them. So the front of the ear one, you'll kind of have to decide which one of these face ones it is. Whichever one of these arteries, and I'll actually just tell you. So the facial artery is the one that you can feel if you press down on like the fleshy part in front of your ear. So a lot of times people look up, like the common pressure point on your face, and the first thing that comes up if you Google it is superficial temporal artery. But the one we're talking about that travels in front of the ear is actually the facial artery. Okay, so after you have done kind of the basic blood pressure stuff, the dive reflex is the next exercise. So you can follow this procedure. You won't be using the BioPack software, but obviously you can't do that from home. You can do this though without BioPack. The only reason that we hooked ourselves up to the BioPack system this week is because it allows us to measure individual heartbeats or individual pulses and measure, like the time between those R to R peaks of the QRS complex, just like we did last week if you were in class for that. And so it lets us get an individual heart rate just for like one heartbeat and measure that time, which is a much more accurate way to capture some of the changes that happen with the dive reflex. Since you cannot do that, just, feel that pulse pressure point on your wrist and measure your own pulse or heart rate for 15 seconds and multiply that by 4 to get your beats per minute. It won't be quite as accurate as doing this in class with the BioPack software. Because as you submerge your face in cold water, your heart rate should gradually decrease. But, when you take your pulse for 15 seconds, you're taking an average heart rate over those 15 seconds. And so you're kind of losing the end few heart rates where you're actually seeing the most drastic decrease. So your heart rate that you calculate for your dive reflex will probably be higher than it actually would be in real life if you were able to just kind of measure the last few heart rates at the end of that. So try to submerge your face underwater for 30 seconds if you can. So just kind of follow through these instructions. The first thing that you're going to do is just measure your heart rate or pulse sitting at rest. If you have a smartwatch like a Garmin or an Apple Watch, you can use that and just get your resting heart rate sitting in a chair. It's good to sit with your legs uncrossed so you're not constricting any blood vessels, and kind of sit there for a few minutes before you actually take your heart rate. If you've been walking around, obviously it's going to be higher. And then hold your breath as long as you can. And I would shoot for 30 seconds because I think that that's something that everyone should be able to do, is about 30 seconds of holding your breath, and have a family member or friend measure your heart rate for the last 15 seconds. And so at least you'll be getting an average of, the second half, the latter half of that breath holding. And then you're going to get a bucket of water. You can use an old ice cream bucket, or if you have like a mixing bowl, fill it with room temperature water, but like it's chilly in my house in the winter. And so I would usually do a little bit warmer than room temp. You just don't want it to feel really warm on your fingers when you test that water. So room temp is best, a little bit warmer is okay. The key here is to have this cold water that's actually going to stimulate the dive reflex. It does need to be ice cold. If you only have a few ice cubes in there, you're not going to see the dive reflex happen. So it does need to be as cold as you can stand it, pretty much. So when we're in lab, we just dump a whole bunch of ice chips into our buckets, and they do get pretty cold. I am going to tell you right now what you should see for results. I like you guys to just do this, and then I kind of explain to you afterwards, because I like you to see and kind of be shocked by the results that you get. So if you want to, pause this video now, go do your dive reflex, do all these 4 things, and then come back, and then I'll tell you what you should have gotten for results. So if you're ready to kind of do this lab now, come back afterwards, and I'll explain to you why you saw what you did in the dive reflex. Okay, so if you've done it, or if not, I'm going to tell you kind of what you should see. So with the dive reflex, do your data support the occurrence of dive reflex in humans? Well, to know what the dive reflex should happen, you just would read this paragraph up here on your worksheet. So I always compare it to marine mammals, because if we think about freshwater mammals, they're probably not going to dive very deep, because freshwater bodies are just not as deep as, oceanic bodies. But their water that they're diving into is probably also not as cold. So I like to think of marine mammals like seals living near like the Arctic Circle, that are diving for prey. And so it's important that they're able to hold their breath for a long period of time. And so this is just kind of a residual trait that humans still have. There's really no reason that humans need to have this dive reflex, because there's no times in our life that we're having to dive into the depths of the ocean. But it's kind of a cool thing that we still have it. And this is why people in the winter that break through the ice of a frozen pond, if they don't die from hypothermia, obviously that's a risk, but that is the reason that you hear kind of these crazy stories of people that broke through the ice in the winter and they were underwater for, minutes at a time, kind of crazy amounts of time, and then they survived. It's because their heart rate was dropping really low. So this dive reflex allows you to drop your heart rate and conserve oxygen, right? So if you're lowering your heart rate, your blood is not pumping through your body as fast, you are going to conserve oxygen. And you're going to probably conserve energy as well, probably kind of lower your basal metabolic rate and conserve everything across the board there. So seals that are able to do this, their heart rate can drop to 10 beats per minute, and allows them to stay underwater for quite a long period of time. So it's cool if you get this to work. Typically what we see in the lab is that people start out with around, anywhere between 60 and 80 for your resting heart rate when you're just sitting. And in warm water, you might see a slight decrease in your heart rate. So your beats per minute might decrease slightly here. It might also decrease slightly when you're holding in air. But then when you dip your face into cold water and stimulate that dive reflex, we see people drop into the 30s for, heart rate beats per minute, which is just kind of wild. So try this at home. And if you don't get a great dive reflex, maybe add some more ice. Take a 5-minute break anytime that you do submerge your face underwater, because you do need to recover your oxygen levels before you do it the next time. And so you should be able to answer these 2 associated questions with that. So freshwater, animals probably have a dive reflex to an extent, but just kind of think about it as, seals that live in the Arctic and why this would be important for them. And then finally, the Harvard step test. Again, this is something that you can do at home. So if I was doing this at home, I would probably use a step stool. You don't want to have anything that you can really easily hit your shin on. So if you have a chair that is around 20 inches off the ground, or a bench, maybe like an entryway bench, or anything, an exercise bench, whatever you can find. And you're going to do up, up, down, down, and you want to do 20 to 30 beats per minute. So if you have a metronome app, if you don't just download a metronome app from the App Store, you really want to try to maintain that 20 to 30 beats per minute. This is a cardiac stress test. So putting stress on your heart to see how quickly your body can recover. So you'll want to measure pulse at the end of these. And so 1, 2, and 3 minutes following, immediately following, if you can, get that as well. But what we want to know is what your fitness level is, and you can measure that. There's a link that I have on the Canvas page that you can go and measure with your values what your physical fitness is from the Harvard Step Test. And then if you have a younger sibling, you know, usually they're a bit easier to convince, or mom or dad, maybe a friend that you're living with right now. Try to find somebody else who's willing to do it with you, perhaps, and see whose cardiovascular fitness is better, right? So let me just show you really quick what this all looks like on the Canvas page. I think that I have links for everything that you need on here. So this will be your Khan Academy video for the first activity. I just have your equations written out really clearly here for pulse pressure and mean arterial pressure. So use those 120/80 values to calculate that. And then I wanted you guys to know, even though you're at home and not doing this, how blood pressure is measured, like what we're actually measuring there. So I have the steps for that. And then the osmosis video is here. So just watch from 30 seconds to 2 minutes and 52 seconds. Ignore the rest because they go into a lot more detail that we don't need to know for this course. I also have a video on heart disease here. And here's that Mayo Clinic link for pulse pressure and what that means. You know, what can have the greatest impact on pulse pressure. So if you're a nursing student or anybody else interested in going into the health field, I would watch this hypertension video on heart disease, because it gives you a really good visual of like what's actually happening and like what causes people to have enlarged heart and some of these other major cardiovascular issues. The dive reflex, I have it sitting, you know, here, but this is basically the same as your worksheet. So just follow along with that. Try to wait until the last 15 seconds to actually count your heart rate or your pulse, just so you get at least an average towards the end of that. And then the Harvard Step Test. Please just give these things a try. If you're not feeling well, if you're sick right now, try to, you know, talk a roommate or a friend into doing these two things. I know that it might be hard to do that. So if you cannot do these yourself and you don't have a friend or a family member who is willing to, let me know and I can give you some example data so you at least can calculate fitness levels from what you have there. So if you have any more questions over the lab this week, just give me a shout. But I think that you should, this is a kind of a nice week to miss if you have to miss, because you can do a lot of it at home. So hopefully you'll be back in class next week. Other than that, have fun with your step test and your dive reflex.